All right, let's check our understanding of type 1 and type 2 errors, my friends. All right, without further ado, the manager of fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food by placing an order. Based on the store records, the proportion of customers who had to wait longer than 2 minutes was 0.63. To reduce this proportion, the manager assigns an additional employee to drive-through orders. During the next month, the manager collects a random sample of 250 drive-through times and finds, all right, that this sample portion is now 0.576. All right, so it has been reduced. The manager then performs this test of the following hypothesis of a significance level of 10 to see if this is going to work out. All right, so here's our hypothesis. All right, where P is the true proportion of drive-through customers who have to wait longer than 2 minutes to receive their food. Now, the question is this, my friends. We have to describe a type 1 error and a type 2 error in this setting. So see if we can do this by yourself. You can pause this video and we're going to go through in just a little bit. But all right, so let's see if we can do this. So type 1 is where the null hypothesis is true. And so essentially we're saying the proportion of what is it? Of drive-through. Okay, the portion of let's kind of write it of those that that have to wait longer wait longer than 2 minutes, all right, has not changed. Okay, so essentially that is what has happened. All right, so the proportion of, so basically the null is true. Okay, but we actually think it has. But we think, all right, it is less. All right, it is actually less. So essentially, we believe that the extra person decreases the times when actually they didn't. Okay, so we believe, so we can maybe add that, we believe the extra, all right, worker helped lower the drive-through time when it actually did not. Okay, when it actually did not. All right. Now, type 2 error is where we believe, or what is true, is that the alternate hypothesis is true. So actually, it did lower it. Okay, so actually, the extra worker, we can add this, the extra worker may have lowered, or did lower, okay, extra worker, all right, lowered the drive through portion, but we believe it did not change. Okay, so that's actually what is happening here. So in that's type 2 error. All right, type 2 errors is where the alternate is true. All right, so actually that is true, but we think otherwise. Okay, we think otherwise. So in actuality, the drive-through proportion decreased. All right, actually it did lower the drive-through proportion, but we believe it did not change. Oh, in type 1 error, the hypothesis actually is true. All right, is true, but we think otherwise. So that means the portion of that have wait longer to minute has not changed, but we believe it has. So essentially, we believe the extra worker helped lower the drive-through when it actually did not. So which type is more serious in this case? Okay, which type is more serious in this case? Well, and this is where you kind of have to put yourself in this position. So is it paying somebody extra money for something that doesn't work, or is it essentially believe that nothing's worked, all right, but you haven't? So, um, so I guess right here, I'd probably say maybe type 1 error is better, all right, is worse, all right. Type 1 error is worse, all right. And the reason why type 1 error is worse because um, we are actually paying money to a person which has not helped lower, all right, drive-through times, not help lower the portion of drive-through times, all right. And that's kind of bad. All right. Why is that bad? Well, you're hurting the company because you're wasting money. All right. And also you're hurting the people because you think you're lowering the time, but in actuality, everybody has to wait, all right, longer than 2 minutes. And so that's why type 1 error is bad. Type 2 error, on the other hand, is that you're paying an extra worker, but you're thinking, and actually it's lowering the time, all right, so people are happy, but you don't think it's working. So you're maybe thinking about firing the worker or maybe trying something else. Okay. And so right here, type 1 is like you're living in this of self-denial, wasting money and getting more people mad. And so that's why type 1 error in this case would be worse. Based on answer number question, do you agree with the company's choice of a 10%? Why or why not? Well, in essence, is that if you want to have 0.10, that means you're giving yourself more error. All right. And so if you want to reduce the probability of actually getting the error, okay. Okay. And so you don't want to have as much error. Okay. And so you want to know, all right, where you are. So essentially, you want to make sure that you um, identify when it is actually true. Okay, so if it actually is true. So in this one, I would probably say, no, we probably want to reduce that. Okay, we probably want to reduce that. So why or why not? So um, based on this, do you agree with the company's choice of that? No. Alpha may be too high because we want to reduce um, the chance of getting a type 1 error. Type 1 error. So we may suggest, all right, an alpha of, all right, 0.05 or maybe even 0.01. Okay, depending on what we want to have. Because if we're going to pay somebody, we want to just make sure that we actually are getting our money's worth. Okay, that's what we want to do there. And then finally, the p-value of the manager's test is 0.0385. Interpret the p-value. So one last thing we're just going to do is let's interpret this p-value that we have here, 0.05. So essentially what it's saying, so assuming, all right, assuming that the null is true, okay? All right, so assuming that the null is true, okay? And what is the null? All right, the proportion of those having to wait 2 minutes or longer is 0.63, okay? So assuming the null is true, there is a 0.0385, all right, chance that we would get a sample proportion of, what we got? And what's our sample proportion again? 0.576 or lower. All right, of 0.576 or lower. Okay, that is what we know. All right, a sample proportion of 0.76 or lower. So assuming the null is true, there's a chance that we would get a sample proportion of 0.76 or lower for those drivers, for those having customers. Add some context here. Customers having to wait, all right, 2 minutes or longer in the drive-through. All right, and that's what we have. And you could add that context maybe in the beginning, but I just put null hypothesis in there. Okay, so assuming that we have this, there is a 0.038 chance that we would get a sample portion of 0.576 or lower for those customers having to wait 2 minutes or longer in the drive-through. And actually right here, we would actually, if we would go through here, we would reject this null hypothesis. All right, we did find convincing evidence because that we did find convincing evidence that we actually did lower the proportion of those that are waiting in the drive-through 2 minutes or less, and so that's a good thing. Much lower than the 10% that we needed, and so that's good. All right. Well, I hope this helps you out on how you can understand level type 1 and type 2 errors when dealing with hypothesis testing. All right. Good luck and God bless in the rest of your problems.